Welcome back, Andy here, to the second part of my laser video series. Today we're going to quickly unbox this laser and we're going to assemble it. However, I did have issues. I am used to assembling 3D printers. I've got a Creality Ender 5 Plus, which is made of the same profiles. When I assembled that, there was a few tricks I had to learn to get that square, but this laser, when I assembled it as per the manufacturer's instructions, it was not square. And I consider this one of the most important things, other than when you're using the laser, you always wear your safety glasses, that you get right from the beginning. Otherwise you're going to be chasing yourself when things aren't cutting square. So you are going to need an additional pieces of equipment than the manufacturers tell you when you assemble it. So if you've got them, where are they? If you've got a square, bigger is better. Or even a little square. This is 200mm square. That's going to help you. If not, you can improvise, adapt and overcome. You can use a sheet of paper. Now if you're going to use a sheet of paper to check it's square, it's better than if you've got a piece of card and you then stick, using some masking tape, stick the paper along this edge and along this edge, so now the paper has become stiffer, and then you can put that in the corner of the profiles to help you square this laser. But there's one important ingredient that you're going to need, and you're going to have to go into the kitchen to find that. What have I done with it? So here it is, tin foil. Yes, you're going to need tin foil, and I'm going to show you in the video why this is so important, and it's going to make you build your frame as square as we can with the tools that we've got. Anyway, let's nip down in the garage. I have pre-recorded this video. I think I've missed a few bits. I'm going to have to edit the video. The bits that aren't so important I'm going to speed through at a higher frame rate, but the important bits I will stop, especially when I'm adding the tin foil, to show you exactly what I'm doing. It doesn't take you that much longer to do, but it is important. So let's get down in the garage and get this damn thing built square.
And welcome back. So this is going to be an unusual unboxing video of a laser diode. It's a Longer 5 10 watts, and I'm going to show the assembly in sped up time, but I'm going to stop at some key points because there's a lot of videos online already about these lasers, but there's some key points missing about how to set it up square, how to adjust the wheels properly, and how to get the best use out of it. So this is not sponsored. I paid for this with my own money, and this is going to be the first video, or depending when you're watching it, of many videos, because this is my machine and I'm going to improve it. I've got lots of plans for it, and I want to understand, one, how the diodes work, how it focuses, how to get it to cut better than many show online. I've got an enclosure idea. I've seen lots of enclosures online and none of them really flick my switch because I don't like the way they work. Anyway, let's get this bad boy unboxed. So obviously the instruction guide, and I do urge you to read that, and declaration of conformity. So yes, these lasers are dangerous. They're not toys. Some people unbox them and say, I've got my new toy, but this is a tool, and a tool which is dangerous to your eyes. So as with all these lasers, it's nicely packed. The first thing I'm looking at is 4 filings on the end of these cuts, and there are none. So let's get it unboxed and see what we have. So there's all the parts laid out, and is it what you expect really? Some aluminium profiles, some parts to assemble it, and they are numbered in steps that correspond with the instruction sheet. You got the laser, you've got the adjusting thumb screws when the laser's mounted on the gantry, you've got the focusing gauge. Now I'm not sure I'm going to be using this, but that will be in another video. You've got a thumb drive with a TFT card there with videos on how to assemble the machine, and some test files, belts, some material, a tool for adjusting the wheels, and that's very important, which I'm going to cover. Materials, a brush, 3 legs, don't worry about the 4th leg because the screen's the 4th leg, safety glasses, and these are labelled OD4 CE mark with a range from 200 to 2000 nanometers, and we're going to be testing these in later videos. A standard cord and a power cord. So let's clear the decks and start assembling this. And I'm going to whiz through the assembly, but I'm going to pause the video and put a title on the screen. So if you are whizzing through the video, when a title appears on the screen, that's a signal for you to stop and pay attention, as it's a part in the video that you need to have a closer look at. So first thing I always do, with even like when I'm assembling my 3D printers, you want to check the profiles that are straight in relation to one another to make sure you haven't got any bent ones. All I'm doing is putting the two parts together and turning them around and making sure I don't really see any daylight between them. So that one's okay. This one's fine. Keep turning it around all four ways. Okay, and okay, they look pretty good. And I do like these profiles because they've actually got, unlike my 3D printers where I've got 4 open channels, you've got one side which is flat here, and that's going to make the profile stronger. Obviously good for their logos. You got, that's going to be the front, that's going to be the back, that's going to be the side, and that's going to be the side. So, and you've got the graduations on the rails as well. So I do recommend that you get a nice flat baseboard. Now this may not be the baseboard that I'm gonna finally have my machine on, but it is a sheet of 18mm MDF, and what that's going to do is going to help us assemble this frame nice and square. So let's get on. We've laid the parts flat out on the table, and the important thing is longer name goes at the front and the stop pin goes on the top left hand edge. So these are the internal brackets. They are symmetrical, so you can't get them back round the wrong way. In the toolkit you got some Allen keys, you've got a spanner to adjust the wheels, and you've got 4 bolts so you can't get the bolts wrong, and it's all in step 1 and step 3, so just follow the instructions. So here I am trying to square my frame up, because when I loosely assembled it, as they say in instructions, my frame wasn't straight. So I've given up using my posh professional square, which I did pay quite a bit of money for, because it's too difficult to use because of this offset. This bar is in the middle. So I've gone back to using my plastic set squares that I haven't used for, wow, 20 odd years, I'd imagine. So what I'm doing, I'm laying that on the bed, and depending which way the frame is angling, in this upright the frame was angling outwards, so I've put some tin foil folded over several times, and it's trial and error, and now I've got no gap here, so I can't even get a thin bit of tin foil there. So I'm going to work my way around the 4 corners now and see whether the last corner I can get square as well. So
just trying to explain to you what I'm doing with the tin foil. When I assembled the frame with the bolt going through here, nipped them up with the corner brackets in, when I checked the squareness, it wasn't square. This frame was pointing over to the left, so that is exaggerated how it was. Obviously I saw no gap there, but that's what the set square was telling me. So what I'm doing with the tin foil is, it's trial and error. I ended up folding 4 folds of tin foil. So then what I did was, you've got the bolt going through the middle, so you can only press it in from the bottom up to just under halfway, or from the top just down to halfway, depending what way you're trying to push the profile. So if I want to push my profile to the right, I'm putting the tin foil in the bottom, then doing the bolts up, and what that is doing is it's forcing the profile to go over to the right hand side, which I wanted. So once I got it in the position what I wanted, and I did this 2 or 3 times to find out how many folds of tin foil that I needed. Once the tin foil was in, I just got a very sharp edge, and I then trimmed the tin foil off so it looked neat. So that's the trick of the tin foil. You're not roasting a chicken this week, you're fixing your laser machine. Trying to check now across the corners to see whether it's square. So I've put some masking tape on the board, and what I'm going to try and do is going to lay some tape on the corner. If you've got a really sharp pencil, that might work. In actual fact, I think I'm going to do this corner here because it's going to be easier for me to look at. That back corner's there a little bit hard to see, so. So that's, I can get rid of this tape here. So that's defined that corner. So if I turn it round like that, now the thickness of the tape helps you line it up because it sort of drops down into the, and that seems fine. So if you had used a pencil, the tape is say 0.3mm thick, and the frame's dropped into that. So I think that's quite square. So take a bit of time squaring up your frame and it will pay dividends later on. So if you've got a longer ruler, you could put a magnet on the underside of that, extend it through here and put a magnet, but I'm quite happy with that. So I'm just going to check now. I keep using the wrong Allen keys. There's this one. Just going to check that all my bolts are just nipped up. Right, well that obviously took a lot longer than I was anticipating, but it's vitally important that you get your frame square. So let's now move on to a bit more exciting. So what else we got to do now? So it says put the gantry on. Maybe that won't go on, but I want to go over the gantry because I know there's an issue with the gantry. So let's put the frame to one side. So the gantry now comes all pre-installed, so you've now got the joining bar. So you've got one motor which is going to drive both ends, and I'm just checking here that the motor spins nicely. And with a stepper motor there is a slight cogging, so if you turn it really slowly, the way it's engineered inside, you can just feel it clicking around. That's perfectly normal. But I know I've got an issue with the gantry. So what's my issue? I'm holding the profile in one hand. I'm going to move the gantry backs and forwards.
and it's going to be very difficult to show you this on camera, but I'm going to say when I feel the issue. So this is where the gantry comes out the packet. So what I'm going to do is, what can I mark that with? Let's see if a pencil will mark it. So I'm going to put a pencil mark on the top of the wheel. Oh, I can just see that. So on the top of the wheel, and the edge of the wheel roughly is, in my case, I'm going to put my thumb on 140, and I'm going to move the gantry to the right, and I'm going to stop when I feel any resistance. So just going to push it with my thumb. No, I'm going to go back because I didn't feel it. So I'm going to put it in. So that's really 145. So I'm putting my thumb at 145, and I'm going to rest that down. Not so easy, is it? I'm going to rest that on the table and just move the gantry, and I shouldn't feel any notching. There. Right. So I've gone from 145 to about 210. And that, I'm going to slide that back. And again, when it gets to 145, it stops because I know I've got a flat spot on some of my wheels. And if I slide to the left, it will go to about here, I'm guessing. Again, it stops here. So I've got flat spots. And what's caused that is we've got on the bottom, you can see here, you've got a nut. And that's an eccentric nut. And it's used to put force on the adjusting wheel. And I'm going to take mine out. What one do I need? See, now that's already now a lot easier to move. So what that meant is, is that wheel was that eccentric nut was squashing all three wheels onto the profile, which is kind of what we want. But if it's excessive, it damages your wheels and gives you flat spots, just like a puncher. You know, it's only flat at the bottom, isn't it? So I just want to remove this and show you a little trick that I do with my 3D printers. And to those that you aren't aware, if you haven't done 3D printing, you may not know what this nut is. So I'm going to take that off. There's probably a washer there. Yeah. I'm going to push that nut through, or that bolt through, and take it all the way out. Now I'm going to be careful that there might be a thin brass washer. Some have it, some don't. No, yes, there it is. You see that little brass washer? So, and that's very unusual for the bearings to pop out that easily. So let's take that all off, and this is what I want to show you. So that is the eccentric nut, and I'll put a graphic on the screen, and hopefully you can see that the middle is off centre. So if you rotate this nut around, at one point it will make the wheel far away from the profile, and if you turned it 180 degrees, it will be pushing the maximum force onto the profile. Now we want somewhere in between if the brackets have been engineered nicely, and if it's too tight you will make flat spots on your wheels. So let's just show you a wheel. So in actual fact, that copper washer or brass washer has fallen out because it goes in between the wheels, so that would pop in there and that one would go back. Now while that is out, just gonna roll that on my finger to make sure the bearing's smooth. Now that one, yeah, look, that's really unusual that the bearings come out, because on my 3D printer wheels they don't fall out, they're in there quite stiff, so that's no problem. So again, I'm just going to check this one while we've got it out. So I'm holding the middle and that's turning nicely. So I'm going to put that back together now, because I'm going to push that in. Make sure you put the washer in the middle, and then put the other bearing, and it doesn't really matter which way these bearings go. So now you can see this is really floppy, and it's allowing it to twist because we've only got two wheels there. So what I'm going to do, I'm going to reassemble it. So you're going to put the bolt in, spacer, and then I'm going to slide the wheel in, making sure the washer is in the middle. See, it's horrible when they drop out like that. But if you ever have to change your bearings, it makes it easier for when you're changing your bearings. So I'm going to slide that on, and it's pushed the bearing out again. I've just remembered why I'm taking it out. What I want to do, I want to mark either the smallest position here, or the maximum position. So I want to get a Sharpie pen, and I have a Sharpie pen in my collection here. And what I'm going to do, I'm going to mark on the crown there, either side of the hexagonal, just there, so I know that is where the frame is. Now I'm going to just draw it on my... So I've just made a note down here. So if I draw it again, if I draw it in here. So that's my wheel, that's the top bit, and I've marked that bit. So reminding me, I've marked where the smallest bit is. So what I'm going to do now, I'm going to push that with the mark facing me in its hole. Then I'm going to put the spacer in, slide the nut in. Now when you're doing that, you'll notice that the washer drops down. So I might have to do this upside down because that's going to keep dropping down. On wheels with tighter bearings, the washer is sort of pressed between the two bearings and it doesn't move so much. So okay, so I've wiggled that through. Now I'm going to put the spring washer back on, and the nut, and these are nylock nuts so they won't vibrate loose, so that's good to see. And making sure that that nut remains in its upright position. That is not the right spanner, Andy. Let's find the right spanner. I'm going to do that nut up. And it doesn't have to be super tight. And now I'm going to rotate that nut using the spanner that's provided. So the black mark is upmost, so that means that you can see now the gantry is wobbling, because we know now what position that nut is in, and it's in its loosest form. So what I'm going to do now is gradually, and I do mean gradually, rotate it in one direction and check for wobbles. That's still wobbling, still wobbling. Getting better, and now I am almost turned it a quarter of a turn. Right, so that now is just a bit of wobble. So my black mark now is horizontal. So I've turned that screw a quarter of one turn, but I can still feel the notching, because that wheel's been stored in the box when it's been shipped, compressed, and you know, I had no idea where that nut was adjusted. So if it was adjusted too much, then it's going to compress the wheel. So all I'm going to do now is move this wheel backwards and forwards. And hopefully what that's doing is just moving the rubber or the whatever it's made of on the wheel. Right, there is still a slight notch there, but it's nothing like it was. And in actual fact, what I'm going to do, I'm going to loosen that off a little bit, because the way I like to adjust these wheels is, you have to do it on the, well, you can do it on the bottom. If you can turn it turn the wheel and it slips round, in actual fact, because the bearings are loose in here, you've got no idea whether it's the bearings, the wheel slipping around on the bearing. So I would say if it falls under its own steam, which you can only test out of position, that's fine. So I'm just going to work it a little bit more. And this is a test that I always do. Before I start 3D printing, I always just move the gantries. When this is all fully connected, you must move these motors slowly because they would act as generators. And depending how good the electronics are on the board, by moving these quickly, you can create a voltage, and you don't want that back voltage going into your board. So I just move my carriage slowly. And again, there is the slightest notch on that, but now I've released the tension on the eccentric nut. Tomorrow morning that's probably going to be fine, but if it's not, tomorrow morning I now know that I'd have to move the black mark down towards the 6 o'clock position to make it looser. So I'm going to just give that a fraction. And you know, I hardly moved that, not even 1 degree, sorry, the nut's under there. I haven't even moved that 1 degree. And that is a big adjustment. So, you know, you don't want to be going from here to there as an adjustment, because you'll be squashing the wheels down too much. Once you get it snugged up, it is literally a movement that you can hardly, well, you wouldn't see it on camera, but you can feel by doing it yourself. So that is vitally important to get rid of that. And I'm hoping that'll be smooth in the morning. So that's okay. So I'm going to, while I'm at it, I'm going to take these eccentric nuts off the bottom as well, because I want to mark them. So I then know that they're all the same. So it's like anything, setup is key. I know we're all excited to get the laser assembled, but I can tell you my Ender 5 Plus that I assembled, if you just take your time, you'll be way ahead of the others who struggle with things not printing right. So again, this one's obviously made the same. So I'm just going to mark either side of the hexagonal the loosest bit. Take the eccentric nut off the bottom. That's the easiest way. Yeah, that was stupid. If I take the bottom wheels off, you stupid man, it will go on easy, because that's what's stopping it. And although we have squared our frame up, once we get the laser working, just taking this motor off, so this nut off, there's tests we can do to see whether it is actually cutting square. So now that should slide on, because we are up there. We can drop that down on there and we're in. So I'm going to turn that over, being careful not to drop now, like that. So you just need to rest it on there, and now we are doing the nuts that wheel, that, and the nut, and is it this one? Right, just be careful that when you're doing it back up, that before you tighten this up properly, just put the mark back at the loosest setting, because we know that's where we want to start off from to get the adjustment. So again, just snugging these up. Hold this bit when you're turning it round, and then we're going to push that through, push that in, mark at the top, get the wheel on. Spring nut and washer. And obviously, you know, I'm working around a camera tripod here. I'm only working in my garage. I don't have a posh studio. So making sure the black line is at the top. So now we should have a working gantry. Hey, that's nice and smooth. Don't worry about it being wobbly, because we're going to adjust the nuts later. What I'm going to do before I put this one on, I'm going to use this last bracket to place on the top of the angles, and I'm going to do those up, and that will try and make sure that this bracket is sit level, because let's see if there's any play in the legs. There is a bit of play left and right, so I'm going to put that on, pressing now slightly down on the table, just nipping those up, and then just snug it up again, not tight. Then again, you shouldn't feel, now I do feel, I can feel a lip there, so I'm going to do that again. That's better, it's no lip. So then with that bracket just loose, again I'm going to do the same thing. I'm going to press down on that. Frame on. We can put the control panel on. So be careful on the back of the control panel. There is an item sticking out, and that is a LED that senses infrared light, I assume, which is the flame detector. So this is just saying it's a 10 watt model, 12 volt, 5 amp, 60 watt rated voltage, machine size, serial number. So I'm just going to take a photograph of that. Just use the camera. So I've got that recorded. You need the small nut bolt to go in this side, because you've got the bolt going through there. So again, like there, I knew something was wrong because the bolt wouldn't go in. So don't force things. Step back and think, what have you done wrong? So this one is the other bump stop. So we got one here. So this bump stop goes this side, pre-installed. So don't worry about this. You can see on the camera this is racking, it's called, because we've got the eccentric nuts unadjusted at the moment. So let's get all the cable out of the way. Fold that back a bit. So I'm just rolling that back a little bit to see if I can make it easier to get the belt out the track. I think what I need is a flat bladed screwdriver rather than an Allen key, and that will help me just lift that up. Okay, once you get it up, try not to drop it. then that's going up over the cog. You can pull that through, down past the wheel feeding it backwards. Oh, twisted it. So it's going to be easier for you guys because this camera frame is getting in the way. Okay, so we're somewhat there, so I'm going to push that through, pull that through, because I want to get that at the back. Okay, let's see how that fastens on. So we've got 4 T-nuts. So we're going to use the T-nuts to secure it back and front. So the way the T-nuts go on is the T shape goes towards the nut, the bolt. So what you're going to do is drop that into the channel, and as you do the bolt up, it should twist. You don't need much pressure because there's a lot of force going on that T-nut. So I'm just going to do the back one as well. So again, assemble the thread to begin with. We're going to get this front one in. So let's just see if we can zoom in here. Okay, so we're just going to drop that in the channel, and as you don't even do it, it's already twisted around, and because the shoulder of the T-nut is square, it locks itself in the channel. So now what you're going to do is, I'm going to say gently pull that, and actually I'm going to change my mind. No, I'm not. I'm going to leave that at the front. So gently pull, making sure that the belt is around the cog. Gently pull and gently pull that up. So now we've got one side done, we've just got to do the other side. So I'm going to try this a different way. I'm going to try it doing it this way and see whether it's easier, because I can actually see more what I'm doing. So I'm using a flat bladed screwdriver to flick up the belt, get it over the cog, back under the wheel, and then make sure it goes forward. Much easier doing it that way. So T-nut, put the nuts on. In fact, I am going to change my mind the way I'm doing this. I am going to have the belts hanging out the back, so I'm going to loosen this off. Didn't expect that to do that. Okay. I'm going to loosen that off. Yeah, I'm just going to do the same. So they're alright doing it up, but they don't like being loosened. So I'm going to get the belt so it's just barely out the front, just to make it, actually I'm going to get it flush with the front to make it look nicer. And I'm going to put that one in first. When you're putting in the T-nuts, it's important that you've got no thread sticking out the bottom to begin with. And if you're struggling getting them to turn, you can just use the screwdriver to lock it around and then nip it up. Okay, then I'm making sure again, because I've adjusted it, that the cog is in. I'm going to put it in the back, twist it. I've twisted it with my fingers and it's done fine. Gently pull it, and that's done. So again, don't worry about the cogging. So how are we going to get this level? So that is on its stop, 10 and 10. So okay, so we want to make sure now that this gantry is parallel to the front of the frame. We've already squared it up. The easiest way I've done, I've taken off the right hand side bump stop, so now the gantry can come all the way forward, and the only thing stopping it is the laser plate hits the front of the frame, so just be careful you don't force it. So I'm going to put that in the middle, and with it in the middle, this side is already fixed because we've tensioned that side up. So now we've got to tension this side up. I've made it slightly more difficult myself because the tension is going to be that side at the back. So let me just slide that through. Yeah, I am going to not do it that way. So my idea is I'm looking down the front of the laser plate, which is just touching on the left hand side, moving that across, and because we're untensioned, I've got a gap. So I can pull that now to touch. I need to get my last adjusting nut on, and I'm going to be leaning across the table to the back to get that last nut in. I'm going to right, because I've still got the gap there, I'm one cog out, so I'm going to release the tension, lift the belt up, move that forward so it's touching, and put it back down. That's near enough for the moment because we can always adjust it on the pulleys. So we've got that near enough. So what I'm going to do now is I'm going to tension the roller wheels. And the way I'm going to do that is the bottom wheel on the left hand side, I can spin that quite easily with my fingers. Now whether that's the wheel and the bearing spinning or the black wheel spinning on the bearing, it doesn't really matter, I don't think. So to get in there we can do it there. And I'm going to go down for my adjustment, and as I go down I'm spinning the wheels. That's spinning freely, and we know we're going to need about a quarter at least of one turn. Just turning the spanner over. So now I'm going to have to lift the frame to be able to get on that. Now I'm going to do it a little bit more, because I can still very easily spin the wheel with my finger. I have to lift it up again. So I can just turn that wheel with my finger, and that seems good enough. So I'm going to do this side now. I'm holding the gantry and moving this nut down. This wheel I can turn with my finger quite easily, so I'm going to go down and still turn it, down a bit more, still turn it, down a bit more. That's too tight now, too tight. I can just turn that. So I'm going to put that down. Now we shouldn't have any racking either side, which we don't. So all we've got to do now is, so I am not quite parallel with the frame, because this side I've probably got 1 mil here between the faceplate and the bar, and the left hand side it's touching. So when it's this side, it's touching, and as I bring it across, it's 1 mil. So that's because we've only got the resolution of 1 cog. So what I'm going to do is I'm going to loosen the grub screws on this coupler. So we've got 2 little bare, oh, I'm going to do the right hand side one, which will allow me to move the right hand gantry to square it up. Make sure your Allen key is in all the way. And I think that must have had Loctite on, because that's quite stiff. So what I should be able to do now is be able to turn. No, that's still not undone enough. So what that should allow me to do is turn one side. See, now the right hand side is racking. You can see I'm moving that on the left hand side. So I'm gonna get this side touching, move it across, then I can bring this side touching, that across, it's touching, and then would you know it that the grub screws are now facing downward, so I'm going to have to use the angle to get in the grub screw. Just can't see what I'm doing here. So that's done up. Screws. I'm just using a block So when that is hard up against there, when it goes across here, that's now hard up against, and I can actually get to the grub screws now. So I'm going to hold that on there, going to knit that up with the ball end. And before, you shouldn't do things uptight with the ball end, you always get the, then I'm going to take that out. And that is good. So move that back and make sure. And that was introducing this gantry being able to wobble top to bottom. So I've tightened or snugged these two up and made that tight. And now what I can do, I can release some of the tension on my eccentric nut, because earlier I did it up tighter than I would normally do a 3D printer wheel. So what I'm going to do, I'm going to just drop that down, and that's looser now. And if I'm holding the gantry, I can almost rotate the nut. Sort of, I can, because I've reduced the tension on the nut, I can now hopefully not get square wheels. And the only wobble in that now, that is now too loose. So I'm going to come back up slightly. Okay, so I'm holding the gantry bar on the left hand side where the motor is, and I'm trying to pull with this plate front to back, and there is no wobble now. The only thing that's doing it is there's a, you know, you pull it hard enough and you can twist the top gantry. So I think that will do, but in the morning I'll come back and do the flat wheel test, and then if that's fine I'll put the laser back on and finish it off. Anyway, that's Andy had a good day. Right, hopefully that's all the hard bits done. So we got a square frame and belts are on, wheels are tight, and again in the morning when I come back down I'm going to move this slowly this way and that way, and I've still got a slight notch, and it's every time the wheel's gone around one turn I can feel the notch. So it's there, 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 but hopefully that will wear itself out. And then again I will move this slowly backwards and forwards, doing it slowly because we don't want to back voltage any of the electrics. So that's that. So now the exciting bit, we're going to mount the laser. So it's heavier than I was expecting, and in another video we're going to be upgrading this, but I do want to have a look at this. So it's good that this red frame goes up and down, because that's going to help with one modification I want to do. So I'm going to take this off for the moment because I want to measure something. I want to measure in there. So I'm just going to take these two side grub screws off. I think they must have Loctite on, because that doesn't want to snap off. So make sure your Allen key is in the grub screw when you're taking that off, and just gently putting some torque on there, and that one's come off. Making sure the Allen key is all the way in, gently, and it's gone. So you are going to have to take this off when cleaning the laser, possibly, but because I've got some modifications that I'm going to do, I just need to measure a part. So that's metal and it's quite heavy. So this is a glass protection lens which is in front of the laser. So if smoke should get up in your laser, you need to clean this part. And all it does, it unscrews. Don't drop it. I'm going to do it this way to make sure no glass falls out, because I know there's a piece of glass in there, which is replaceable. So in there is the actual laser focusing lens, and that's hot glued in there. So that's not going to move, which is good. And I'm not going to take that out now, but I wanted to measure so 14mm is the glass lens, and that would fit in there, but I wanted to measure this part as well. 18. So what this is here then is the laser module. You've got a cooling fan here, and this is the driver board. So air is being sucked down, blown through the laser module to cool it, and then the air is being extracted out of the nozzle of the laser. So it is giving you some form of air assist, and it's trying to prevent smoke going up into your glass part. So that helps with the cutting. If that gets dirty, obviously your laser's not going to cut very well. So yeah, there's going to be modifications to this to make it better. So now this, I'm going to leave the shield off, and let's find the last bag of stuff. So step number 6. Don't lose the 2 little plastic bits. So that so there is about there is about 50mm travel on that, which is quite good. Right, you got to be careful. So maybe they're not done up tight enough. I'm going to do them up a little bit tighter. You've got to do the 2 screws at the back tight enough so when you raise the laser to its maximum height, you can see a gap between the head of the screw and the gantry. Otherwise it will rub on the front profile and scratch it. So that's fine. So you've still got that movement. Okay. What I've got here is now I'm rocking the gantry. So my wheel at the bottom isn't tight enough because the laser head is moving front to back. So I'm just going to nip the wheel up on the bottom, and I need to go up. So my black mark is at 9 o'clock at the moment, so I know now I need to come up to tighten it. So I'm only going to do a fraction of the degree. do a bit more. Okay, that's better. So again, what I'm going to do, check in the morning that that slides nicely and I don't get the clonking noise at every one revolution. So I think we're there. So I'm going to leave that for tonight. I'm going to come back in the morning and sort that out. So the frame is 21 inches. So if you was going to cut a wasteboard, I would have at least an inch. You would really want 23 by, yeah, if you had 23 inches or 23.5 inches and you made it 600 square, because on the outside there should be right, I have seen other channels where they have brackets which screw the laser down, so we haven't got any. That's very disappointing. So the first thing we're going to have to do is we're going to have to design some legs to stop it.
Well, I really thank you if you got to the end of that video. It was a lot longer than I was expecting, and I've stopped it without installing the wiring, because in the next video I actually stripped the wiring harness down because I really don't like it. It's so stiff, and I want to add some additional cables for future, because I'm planning on adding a Z-lift and limit switches into that, and I also add an air assist tube. So that's my next video showing you the wiring harness. I cut it apart and changed it all. So if you like the video, please leave a comment. Like and subscription is always very well welcomed. Let me know if you're enjoying these videos. That's Andy now signing out. Many thanks for sticking around to the end of the video. You might like to watch some of these videos popping up on your screen now. Let me know what you think in the comments.